Hello there, and welcome to this collection of notebooks and tutorials on machine learning for audio signals in Python. This is a course offered by Professor Schula at the UMNL University of Technology. I am Renato, the instructor for these online materials, and on this notebook we'll talk about neural network detector for the MNIST digit recognition. So let's get started. In the last part, in part 3, we saw how to use a classifier network for the MNIST digit recognition. At this time, we will change our strategy and we will use a detector for the MNIST digit recognition. In such case, it makes sense to use a detector as in part 1 for the recognition because it has the advantage that we can train the recognizer of each digit class to output a 1 or a value close to it when it recognizes its digits, or a 0 or a value close to it when it's not recognizing its digit. If no digit is present, all detectors will output values close to 0, which is something that the classifier cannot do. For that, we are going to use the same neural network structure as in part 3 for the MNIST classifier, but with a different loss function. Instead of the cross-entropy loss, we will use the mean-squared error loss. But we need to take into account that the mean-squared error loss expects a different target representation. For the cross-entropy loss, we need the class label number as a target, which means we have one integer or a float input digit. The mean-squared loss expects a float number for each class, which means 10 float numbers for each input digit, where the correct class should have a 1 and all other classes should have a 0.